right? Summation of the forces, including reaction forces, it should be equal to 0. And the movements caused by the different forces on the machine member should be equal to 0. Then only the structural member is in equilibrium state. Okay. Now let us take one example. So now you are observing a garden bench here. You just observing a garden bench. Let us look at it. You got a one support on left hand side. So you got a one more support here. So what I'll do, I'll just go for marking the, let us say this is what a left support. Let us say this is what a right support. Okay. You can imagine you are sitting in a classroom on a bench with your friend. Okay. Now let us take distance here is around about 1.2 meter. So we just made an assumption here. We got a one bench. So bench is supported by two supports here. So this is what a left support. This is one is a right support. Okay. Now what is the distance between these two supports is? Distance between these two supports is it is 1.2 meter. Okay. Now let us take an example. One person of weight 1000 Newton is sitting from this left support at a distance of zero point 0.3 meter. Okay. And another person sitting on this bench whose weight is 900 Newton and he's sitting at a distance of zero point 0.5 meter from the support. Okay. Now, if you go for drawing the force diagram for this bench, now this is what a left support. This portion is, this is what it is a right support. Okay. Now supports are giving some resisting force which is going to act in upward direction. Okay. Which is going to act in upward direction. We are going to call that as a reaction force. Okay. And left side you got a one reaction force and right side also you got a one reaction force. Now we're going for just a support diagram. Okay. Person A, this is what person B, he is a person B. Now we'll just make a position of person A is how much? He is sitting at a distance of 0.3 meter and he is weighing 1000 Newton. Person B, let us mark person A, person B. Person B weighing how much? He is weighing 900 Newton. Now he is sitting at a distance of zero point 0.5 meter from right support. Now, what is the condition? Bench is to be in equilibrium state. Okay. So bench is to be in equilibrium state. What are the condition? Summation of forces should be equal to 0 and summation of the moment which is acting on the bench should be equal to 0. Then only we can say bench is an under equilibrium state. I'll rewrite the diagram once again here. Redraw the diagram once again. This is what reaction force on left hand side. This is what reaction force on right hand side. Now what are the distance between these two supports? Distance between these two supports is a 1.2 meter. Now person A is sitting at a distance of 0.3 meter from left support. He is weighing 1000 Newton. And from support R, got a one more person who is sitting at a distance of 0.6 meter. Okay, from right support is weighing 900 Newton. Now just observe, due to acceleration due to gravity, so the weight of this person is in acting in down direction and weight of person B is also acting in a down direction. Now to get the bench in equilibrium state, so reaction forces are going to act on it. Okay. Now if you just observe, download forces are, one is 1000 Newton, another one is 900 Newton. These two forces are acting in a down direction. Now if you just observe, the reaction forces RL is acting in up direction as well as RR is also acting in a upward direction. Now what is the condition? Condition sigma F equal to 0. Now you just observe, 1000 Newton acting in a down direction, 900 Newton is also acting in a down direction. So unknown value here, reaction force acting in up direction. So we don't have the value here. And similarly, the reaction force which is there on the right hand side is also acting in up direction. So we don't know, have any value here. Now we just observe how many parameters are unknown here. Two parameters are unknown here. What are the two parameters? RL as well as RR. Now if we calculate any one value, let us say if we calculate RL, so by equilibrium condition of the forces, you can calculate value of RR. You can calculate value of RR. That is how. So 1000 plus 900 minus of RL value. Now, if you want for equivalent condition of the forces, two forces are unknown here. Okay. Next, another one condition is what? The summation of the moments is equal to 0. What is the condition? Second condition is moment should be equal to 0. First condition you already got it. In first condition what? 1000 Newton acting down direction, 900 Newton acting in a down direction. So RL is acting in up direction. So RR is acting in up direction. So it is equal to 0. You got two values are unknown here. What is the next condition? Summation of the moment should be equal to 0. summation of the movement should be equal to 0. Okay. Now let us see. This is what support on left hand side. This is what support on right hand side. You got a load 1000 Newton here. It is of a 0.3 distance. So now this distance is 1.2 and you got a distance here. It is 0.6. It is how much? 900 Newton. This meaning summation of the moment should be equal to 0. You need to consider any one point as a reference point. Now the summation of the moments about that point should be equal to 0. Then only member is in a equilibrium state. Now I'll mark this point as a L, this point as a, this point as a B, and this point as a R. So how many points I got here? I got a 4 points. L, you can say those points are load points A, B, and R. If I take moment about L point, let us take, I'll go for taking moment about point L. I'll take taking moments, not a moment, taking moments about point L and equating it to 0. Okay. So now from which point I am taking moments? I am taking moments about the point L. Now this is a point L. Let us draw. This is L. So here you got a one load A. Distance is 0.3 meter. Okay. It is how much? It is 1000 Newton. Now if you just observe about this point, the load is causing a clockwise movement here. Movement is what? This is what a distance. This is what a force. So movement is what? It is a distance into force, or if you take length here, this is what? L into F. Now what is the movement on point L because of the load A? It is how much? Distance is 0.3, load is 1000. So you got a 300 Newton meter. Now movement on point L because of load at A, you calculated it is how much? 300 Newton meter. We are considering this left point as a reference here. We are considering left point as a reference. The moment what we got on point L due to load at a point A, it is 300 Newton meter. Next, moment on point L due to load at point B. Okay, due to load at point B. Now let us take, this is a point L, this is what? Point B, which is weighing 900 Newton. Now what is the distance from L to point B? So you just observe it is a 0.6 meter. Now if you take here, the distance is 0.6 meter. Now again it is what, 0.6 into 900, it is around about 540 Newton meter. Okay. Now moment which is going to cause on point L due to load on point B, it is in a clockwise. So here also it is what, in a clockwise. Okay. Now coming to the last one, movement on point L due to reaction force at point R. Now this is L point. On L point you are considering the reaction force. You are taking moment about L. Now this is what, RR. Distance is how much? It is 1.2 meter. Okay. Now what is the moment which is going to cause on point L due to the reaction force at R? Now this is what, in an anti-clockwise direction. This reaction force is trying to push this bench in upward direction. Okay. Now what is here? It is 1.2 into RR. Now I'll take sign as a negative here. I'll take a sign as a negative. Now this is a one value. Okay. I'll write here minus 1.2 into RR, 300 Newton. Okay. Plus 540 Newton should be equal to 0. So 300. So this value. Okay. So moment due to load at a point A. Okay. And 540, this value is moment due to load at a point B here. Okay. Now what is the condition? Condition is summation of the moment should be equal to 0. Then only member is under a equilibrium condition. Now let us go for 300 plus 540 minus 1.2 RR equal to 0. Now it is what, 840 equal to 1.2 RR. Now RR equal to 840 divided by 1.2. Okay. Now if you calculate 840 divided by 1.2, it is 700 Newton. So now this is what, reaction force at R, you got 700 Newton. How much you got here? You got RR equal to 700 Newton. Once you got the RR value here, okay, now let us substitute. So 1000 is acting in a down direction, 900 is acting in a down direction, okay. Which one is equal to RL plus RR? These forces are acting in up direction, okay. These two forces are acting in a down direction, okay. So summation should be equal to 0. Now if you look out on left hand side value is 1900, and right hand side RL is unknown, so RR you got a 700. So now RL equal to 1900 minus 700, so you're going to get 12,000 1200 Newton.